3-2, logarithmic functions and their graphs. Last year, did we do logarithmic functions with the exponential? Okay, so we're just going to step a little further. Again, your book from last year set you so up for this first semester.
I'm still struggling.
It's good. It's good for you. Okay, so every function f of x equals a to the x, which is exponential, passes the horizontal line test. So if I were to graph an exponential function, it's a function, yes, because it passes the vertical line test.
Yep.
Well, it also passes the horizontal line test, saying it's 1-to-1 and its inverse is a function. The inverse of exponential function is a logarithmic function. And I'm going to hit this because I think I have a picture. Evidently, I don't. So a logarithmic function is the inverse of an exponential function. So exponential is y equals a to the x. And a logarithmic function is log base a of y equals x. So this y is technically in parentheses because it's of it. So when we find inverses, we interchange the x and the y, and we solve for y, correct? Mm-hmm. Okay. In this case, we didn't do that. I just changed the form of the function from exponential to logarithmic. How did I do that? Where did things go? Where did the base of the exponent go?
Not in the log.
It went to the base of the log, right? The base of the exponent is the base of the log. And did the x and y interchange places? Yes, because in an exponential, the x is the domain and the y is the range. But in the logarithmic, y is the domain and x is the range. I know that because input-output, right? So this just basically says what I wrote. That y equals log base a of x, if and only if x equals a to the y. They used a's and x's like that. But did a still become the base? Yes? And the x and y, did they still interchange places? Mm-hmm. So it doesn't matter where the things are or what they are, they interchange bases. Good?
Yeah.
So 2 equals log base 3 of 9. Says 9 equals 3 to the second. The base becomes the base, and the x and y interchange places.
So that 9 equals 3 to the second is the answer for that?
Well, it's just this is logarithmic form and this is exponential form.
Okay.
It's not an answer, it's switching forms. So we're going to go from exponential to log now. 5 to the third equals 125. So it's going to be log base 5. And the 125 and the 5 interchange domain and range of 125 is 3. Just remember that log base 5 is a little 5. I know there's some people out there right now that have this on their paper. or something pretty similar to that. That would be 5 times 125, correct?
Yes.
And that is not right. Am I good?
Yeah.
What are you doing with your calculator?
Oh, I was putting it.
Okay, when evaluating logarithms, remember that remember that a logarithm is the inverse to an exponential function. That means that log base a of x equals the exponent, which a must be raised to obtain x. So when we do to solve these, we're just going to rewrite them. Basically, if you're in your logarithmic form, you change it to exponential. If you're in exponential, you change it into log. Okay, so how would you write 2 equals log base 3 of 9?
9 equals 3 squared.
9 equals 3 squared. So that'd be 9 equals 9.
Mm-hmm.
Okay. So what's f of x?
Function.
Like, it is a function. It tells me it's y, right? It is a function. Tells me that, so there's lots of things about it. But when we're changing this, we just want a y, don't we?
Mm-hmm.
So what's my base? 2 to the y equals 8. Well, in exponential, if we have the same bases, we can solve, right? Can I make 8 base 2?
Yeah.
So 8 is 2 to the third. And 2 to the y, so I can use my 1-to-1 property, and the answer is
3.
y equals 3. The 1-to-1 property applies with logarithms as well. And the last one, it's an exponential. Let's put it into what?
Log.
Log. So log base 5 of 125 equals 3. And I know it was just on the other side, but I could give you the same ones over and over. Am I good? No.
Okay.
Everyone? Ainsley, you good? Okay. Okay, so in your book, and I don't know why they do this, they write the problem like this. It says, use the definition of logarithmic functions to evaluate each function. So it's f of x equals log base 2 of x. And then they say x is 32. So why didn't they just write,
Log 2 of 32.
oops,
Log base 2 of 32.
right, log base 2 of 32. I don't understand why, but that's all it is. So it's in logarithmic, I change it into what? Exponential, so I can use the 1-to-1. So what's my base? 2 to the equals 32. So I need to get same base, right?
Mm-hmm.
So 32 is 2 to what power?
Fifth.
So y equals 5. Ooh, you do the next one on your own. Gotta think. Jaden, what's the only power that can give you 0? Give you 1. Just gave it away.
1.
What's the only exponent that can give you 1? Cadence?
0.
0. So this is 3 to the y equals 3 to the 0, so y equals 0. Anything to the 0 power is what, guys?
1.
So 4 to the y equals 2. How do you want to do it?
I don't know what the way they're written, Mr. Easy.
So it'd be 2 to the 2y equals 2 to the what? First. 2y equals 1, so y equals 1/2. Mm-hmm. So log base 10 of 100th. So it's 10 to the y equals 1/100th. What base you want? 10? I need to make a fraction a whole number, so what do I do to its exponent?
Negative.
Make it negative. So 100 is 10 to the,
Negative 10.
how about negative 2?
Sure.
Yes?
Yep.
Negative 10th would have 10 zeros.
Yeah.
So y equals.
Negative 2.
So all of these you saw when we did our exponent practice, correct? But you didn't have to write them into exponent form. So basic rule of thumb is if it's in log, turn it to exponent. If it's in exponent, turn it to log. And you don't know we haven't reviewed the log rules yet, so you won't be doing that. There is a log button on your calculator. It is right here. You know that? Yes? Okay. This log is base 10. It is called the common log because we count in base what? 10. This log right here is called the natural log. What was the natural exponential function? What was the base? Natural things come from the earth, and earth starts with E. So you had e to the x, and now you're going to have, if you have log base e, we just say the natural log, ln. So this, on the calculator, log is always base 10. ln is base what? E. When you see ln, you know it's base e. We never write it like this. That looks funny, does it not? When you have log and then base e, it looks funny. Okay, so here are your properties. You actually just saw it, the first one. So log base a of 1 equals 0.
A 0 equals 1.
Because a to the 0 equals 1. Log base a of a is 1. Because a to the first equals a. Now, I'm going to tell you 2 and 3 are the same rule. Because 3 says log base a of x equals x. Well, on 2, what is the x that's up here?
1.
1. So aren't those the same rule? So if I'm remembering rules, I'm not remembering 4, I'm remembering 3. But you can remember 4 if you want. Okay, the last one is that 1-to-1 property. Oh, I didn't do the inverse. Well, I did do the inverse. But I'm going to talk about number 3 a little bit more. I have log base a of a, so the answer was the exponent, yes? In exponential form, if I have a log base a of x, the answer is the x. Do you see the bases match? So if the bases are matching, the answer is that x, okay? 1-to-1 property, again, the property. if log base a of x equals log base a of y, then x has to equal y, doesn't it? Most important thing here is what? You have to have the same what? Base. These are the 4 properties of logarithms that will help you solve problems to evaluate them. Good?
Yeah.
Okay, so simplify log base 4 of 1.
4, 0 equals,
Or just the answer is
okay,
0.
0,
By what property?
1.
Okay, your work is prop number 1. Okay? You shouldn't have to work that out. I know you were. That's fine, Cadence, because we had been, right? But now since I gave you a rule, do you have to work it out anymore? No. Your work is identifying its property number 1. That's your work. Okay? So all of these have an imaginary x over here because that's what you're finding. So I have log base square root of 7 of the square root of 7. So what's the exponent on the square root of 7?
0.
No. 1. If it's 0, it'd be 1. So my answer is 1.
Why is that one like that?
Okay, because that's that property 2. The bases are the same.
No, I mean the next one.
Oh, the next one? Just because we're actually doing the same thing. Okay, simplify. It says 6 to the, that's all to a power, of log base 6 of 20. Are my bases the same?
Yeah.
So my answer is what?
120.
20. And this is prop 3. And technically this is prop
2.
prop 2, but could you put 3?
2 and 3 are the same.
Yep, 2 and 3 are the same. Except 2 is just for an exponent of 1. 3 is for all of the exponents. So is it important that you guys learn those? Yes. They will make your life so much easier. You won't have to work them all out. To make a happy day.
No.
That person does not look happy.
I think they look amazing. Look at their hair. They're having an awesome hair day. Okay, ready?
Yeah.
Okay, graph. So an exponential function. Well, exponential function, because if I know an exponential function, should I be able to graph a logarithmic function? Because they're inverses, yes? Everything is the same except x and y switch places, correct? So let's graph our exponential. What's the thing we know about an exponential? They all go through what point?
0, 0. 0, 1, 0.
0, 1?
Yes.
Because anything to the 0 power is 1?
Yes.
Okay, so here's my exponential. Yes? Okay. Oh, we had some things we knew about exponentials, right? The y-intercept was 0, 1, right? It had a horizontal asymptote at x equals or y equals 0. Correct? It's increasing. The domain is all real numbers. And the range is greater than 0. Oops. I forgot my greater than sign. Are those all the things we know about it? Is there anything else? Doesn't have an x-intercept, does it?
No.
No. So that's everything we know, right? Okay, so inverses physically take your domain and range and switch places. So your x become a y and your y become x. So exponential had a y-intercept, so logarithmic has a what? X-intercept. So the x-intercept is going to be at what? 1, 0. Exponential had a horizontal asymptote, so a vertical asymptote.
X equals 1.
How about 0?
Yeah.
Okay. The increasing isn't going to change. Still going to change. It's still going to be increasing. Okay. What's going to happen to the domain and range?
Range is all real numbers.
Range is going to be all real numbers.
And then domain is going to be y or x greater than 0.
So the range is all real numbers. And the domain is going to be x is greater than 0. Because we know that inverses reflect across that line, don't we? Okay. So our x-intercept is 1, 0. And we have a horizontal asymptote at x equals 0. Did those two reflect across that line?
Yeah.
Yeah. So if I know my exponential, can I figure out my logarithmic?
Yes.
Yes, you do need to know those basics. Like if I asked you to graph those parent functions, you do need to know how to do that. And we're going to have an h and k here just as we did here. And h and k are going to do the same thing. But we're not moving 0, 1. We're moving what? 1, 0. Oh, we did that. We don't need to do that. Okay, so there's, right there is 2 to the x and log base 2 of x. Are they reflected across that y equals x line? Yeah. Every x, y point, I could interchange places and have the other one, couldn't I? Okay, describe the change. So I am going to tell you, I personally always put parentheses in these things because I don't like guessing if it's an H or a K. The textbook is only going to put parentheses if it's an H. Got it? So is that -1 an H or a K?
Okay.
It's K. So it's our point we were moving was 1, 0. And now it's going to be what?
0, 1.
No. 1, -1. Because it's a K. So it'd be 0 minus 1.
Yeah.
Okay. So it means everything moved down. If everything moved down, because this is my graph, right? Does that change my horizontal asymptote? I mean my vertical asymptote? No. Does it change the domain? No, because I just moved up or down, right? I didn't move left or right. So what's going to affect the most on these is moving left or right, isn't it? I didn't reflect, so the only change is actually this, isn't it? Okay. What about this one? So H is -3. So 1, 0 is going to go to what?
-2. I mean,
Yeah.
yeah.
-2, 0. You just taken that away from your x, right? So that means this whole graph moves back 3, doesn't it? So our vertical asymptote was x equals 0. Now it is what?
X equals -3.
X equals -3. My range doesn't change. That's all real numbers. My domain was x such that x is greater than 0. Now it is what?
X is greater than -3.
X is greater than -3. That's a horrible -3. But does that make sense what's happening? Now, you guys thought you never understand domain and range, and you guys are doing pretty good at it. Just letting you know.
I don't know what you're talking about.
So, when it says describe change, should you say where it started? Yes. Did I state where everything started? Yes. Now, I no longer called it an x-intercept because on the first one, is it an x-intercept anymore? No. On this one, is it still an x-intercept? Yeah, so I could call it x-int if I wanted. But just be careful, because once you change the y, it's not an x-intercept anymore, is it? Nope. Okay. Oh, shoot. This one's, like, weird. I probably should rewrite it, right? How did I rewrite that? I put the negative in front, right? And then did I factor it out of the 2? Yes. So my h is 3, isn't it?
Yes.
Okay. So 1, 0 becomes what?
No.
1 plus 3 is
4, 0.
4, 0. And my vertical asymptote was x equals 0,
X equals 4. 3.
x equals 3. And my range was y, my domain, not my range. Sorry. So my domain was x is greater than 0, right? And now it is
X is greater than 3.
So I want to sketch this real quick because there's something I'm not talking about on purpose. Here
Then don't talk about it.
and here. Yes? What does this do?
I don't know. It makes it reflect on the other side.
Of the y, yes? And our new y is this asymptote, isn't it? So instead of doing this,
It'll decrease.
won't it do this?
Oh, thank God.
Okay, so those kind of twist our brains, and I know they
We have
do.
to do that on the.
I don't think you have it on the homework. We'll work more on it. You may have it on there. Nothing's going to hurt you. Okay,
Brain hurts.
tomorrow is log base E. Guess what? Nothing changes.